In the last video, we saw some examples of recursion, and we said a recursive method is a method that calls itself again. It calls itself again with a smaller version of the problem that it was called with. Now, sometimes in recursion, the method doesn't directly call itself. It might call itself indirectly, and that's called indirect recursion. What does that mean? Let's say we have a method f1, and f1 to do something, it's going to have to call a method f2. And f2, when it's doing its work, it's going to call f1. So here, f1 calls f2, and f2 calls f1. So f1 eventually calls itself. It's calling itself through f2. That's called indirect recursion. Let's see some examples of that. Okay, so let's say we have some code, and we want to determine, we have a number, and we want to determine if this number is even or odd. And we don't have the modulus operator. So the way for us to determine if a number is even or odd, we use the modulus operator. We try to divide the number by 2. If we get a remainder of 0, we say it's even. If we get a remainder of 1, we say it's odd. Or if we don't get a remainder of 0, we say it's odd. Now, what if I don't have the modulus operator and I told you I want you to determine if a number is even or odd? How would you do it? Well, one way you would do it is you would say, okay, well, the base case is if you tell me the number is 0, I know that it's even. Okay, so I'm going to write a method, and I'm going to say if the number is 0, that means it is even, it's true. Now, if it's not 0, what I'm going to do is I'm going to ask the number that's smaller than me. So if you go to 5 and you ask 5, are you even? Well, the way 5 will know if it's even or not is it's going to ask, so if you want to know if 5 is even, I don't know if 5 is even, so what I'm going to do is I'm going to go ask 4. 4, are you odd? Because I know if I'm even, then the number at like 1 less than me has to be odd. If I'm odd, the number less than me is going to be even, because, you know, even and odd numbers alternate, right? So we got odd, even, odd, even. So if I ask you if even is 5, you're going to go and call odd on 4. Now, then odd on 4 is going to say, oh, I'm going to check if 3 is even. And 3 doesn't know, so it's going to say, I'm going to check if 2 is odd. And 2 is going to say, well, I'm going to check if 1 is even. And 1 is going to say, I'm even going to check if 0 is odd. And now the question is 0 an odd number? And we know that 0 is even. So this is going to return false. I'm not odd. So now 1 knows I'm not even. And 2 knows I'm not odd. And 3 knows I'm not even. And 4 knows I'm not odd. And 5 knows that I'm not even. So it's an interesting way of how to find whether a number is false or even. You go to the number under you and you ask it the opposite question. So this is what the code here is doing. It's starting and saying, well, I know that if you ask me a number, a 0, if you ask me 0, if 0 is even, I'm going to tell you it's true. And if you ask me if 0 is odd, I'm going to say it's false. Now, any other number, you ask me, I'm going to have to go and ask the number before me. So when we asked, is 5 even? I don't know. I have to go and check if 4 is odd. And here we're using the absolute value method, so that it should be math.abs, by the way. We're doing the absolute value so that if the number is like -3, you don't go and make it -4, you make it -2, so that eventually you reach 0. So if it's a number that's negative, we're going to take the absolute value, because -3 is odd and 3 is also odd. So we just want to do the absolute value of it. So this is an example of an indirect recursion. Even calls odd, odd calls even. So even eventually calls even, but indirectly. Okay, so of course this code is inefficient, but this would be an alternative if you had to deal with some programming language and it didn't have the modulus operator. You don't have a choice but to implement it, you know, in a similar way. Another indirect recursion example, and this is very common in parsers. So if you think about the compiler, you know, the Java compiler, that goes through your code and tries to figure out if there are any syntax errors. So, the compiler is looking at these expressions that we're writing here and has to say, well, you know what, this is a valid expression. The second line is valid. The third line here, we have 1, 2, 3 open parentheses, so we have to have 3 closing parentheses. So the compiler has to have some algorithm to figure out if these sentences are correct or not correct, syntactically correct or not correct. And so we can, if we try to think of how the compiler does it, it might have a term, an expression. It says, well, an expression is basically, some term, and you have to add a plus or a minus between them. So you have two things that you have a plus or a minus between them. And a term can be a factor, which has a multiplication or a division between it. And a factor is basically an expression in parentheses or a number. So if I'm looking at, 3 plus 4 times, parentheses 5 times 2, well, I'll say that 5 times 2 is an expression. And then I'll say, well, 5 times 2 is an expression. Now, that expression has to come here and be a term, and it might have plus or minus between them. So here doesn't have plus or minus, but the term here has factors and it has the multiplication. So it does have the multiplication in it. So the factor can actually be a number. So the 5 gets here, the number gets propagated to factor. So that's the 5 times, and then another factor, which is another number, 5 times 2. And so every time it goes and asks is something an expression, it's going to have to find if something's a term. And a term is going to have to check if something's a factor. And a factor is going to have to check if something is another expression, or maybe it's just a plain number. And if it's just a plain number, then you're done parsing. But if it's an expression, then you have to call the expression, a method and say, well, are you a term, and so on. So complicated code like this, where you have parsers like compilers or things that parse through syntax, would have to do things like that. Imagine think about Word, Microsoft Word right now. One of the features they have is those green wiggly lines. Let me try opening it up and showing you. But basically, you would have red wiggly lines if you have spelling mistakes. But if you have some grammatical mistakes, it also figures it out. So if I have some sentence and it's grammatically not correct, like I ate chocolate and I don't know, coconut and coconut and almonds and bananas. So it likes this one, but how about if I put some comma here? Let's see. Will it detect that? Nope. Okay, let's think of another sentence that I saw an error message with. It is hot and cold. Okay, so here it has those two lines under and if I right click on it, it says possible word choice error and. So it's it has some code internally that's trying to look and say, well, and needs to come before a word that starts with a vowel, and this word doesn't start with a vowel. So maybe they wanted to use the word and instead. So this kind of parsing, has to do a lot of repetition, a lot of recursive calls. And this is an example of, a recursive call, and Word would be using something like this. So anything that has to kind of parse through your words or parse through numbers or parse through code does use recursion. Another way of doing recursion, so like the last video we talked about simple recursion. Now we're kind of talking about a little bit more complicated recursion. One way is doing that. One example is the indirect recursion. Another example is using helper methods. So let's say I ask you to write a method called SumArray that sums up all the elements in the array and tells me the answer. So without looking at the code here, let's try to do it. If I tell you public static void, or let's make it an int, SumArray, it takes an int array. So int array means I need 2 square brackets. Let's call it array. And if I wanted to do it using a for loop, I would have int, let's say sum equals 0, and then I will say, okay, I'm going to visit every single element in this array. I'm going to start with location 0. I'm going to go until I hit the end of the array. So I'm going to go up to array.length, I++. And what I want to do is I want to go to this array, get what's at location I, and then I want to add it to the sum. I'm going to say sum plus equal array of I. And this would give me the sum of my array. So here I would return sum. Okay, this is how to do it without recursion. So I'm just going to make this called for, because this is using a for loop. Now, what if I wanted to do it using recursion? Now, let's ask ourselves, how can I write some array? You know, if I have some array, I'm calling some array on an array that is 1, 4, 7. What is that equal to? Well, I can say that that is equal to 1 plus some array of 4 and 7, right? I'm going to add 1, and then I'm going to say, well, go get me the rest of the array, the sum of those two elements. And so this will be equal to, I'm just going to write equal here under the sum arrays, because I want to just replace this. I don't want to replace the 1. Sum array of 4 and 7 is the same as saying 4 plus some array of just 7. And if you give me an array that just has 7 in it, well, I'll just tell you that that's 7 plus nothing. So if you give me an array that's size 1, I know that I'm done, right? So this would be 1 plus the 4 plus the 7, and I'm done. Now, how can I write this in code? So I can write my base case if the array has only one element. So this is easy. If the array dot length, okay, well, I can even say if it's 0, then return 0. If I don't have anything, I'll just say 0. I can also say if the array length is equal to 1. If you only give me one element, then I'm going to just return that element, array of 0. It only has one element, right? Just like here, it only has one element. But I'm going to also put the case that they give me an empty array, just to be on the safe side. So this is my base case. So I have two base cases. Okay. Empty array has sum of 0. And this is also a base case where I have array of length 1 just has one element. So sum is equal to that element. Okay, I only have 7 in my array, so my sum is 7. Okay, well, what if you're more? Well, if I'm more, what I want to do is I want to return the first element in the array plus the sum of the rest, right? I want to return array of 0, first element here, the first element in my array, plus I want to say some array, but I want to say the array starting from location 1. How do I say that? How do I say I want the array from location 1? Well, what I would have to do is really create another array, you know, maybe create an array and only copy those two elements. So that's going to be expensive. So what I can do is I can say, okay, I'm going to introduce a helper method that takes the array and takes a starting index. What I want you to do is I want you to call some array, but I want you to give me the sum of the array, but starting with location 1, for example. I don't want you to start counting from the beginning of the array. And so here we would modify this to have like a starting number. And so if I want to call some array, let's go put it in main. If I want to call, if I create my array, let's create an array int a equal to 1, 4, 7. And I want to print out the sum. I'm going to say I want to call the sum array with this array, okay? So here, I'm going to introduce my helper method. And it takes the starting point. Actually, but let's just do it here, because that's the one we need to modify. Okay. So what I'm going to do when they call some array on an array, I'm going to have to say, okay, I'm going to call my helper method. And I want you to give me the array, the sum of the array starting with location 0, because I want the whole array. So they want me to write a sum array that sums up an array. I'm going to do that. I'm going to write one for them. Here it is. But I'm going to internally use my sum array helper method that says I want you to give me the sum of the array, all of it, starting with location 0. Okay, and so here I don't want to be checking the length of the array because that's not going to be right. I want to check if that starting point is beyond or the last element in the array. So here I can say if the length of the array is 0, of course, return 0. If it's 1, I can return 0 also. But I can also have another base case, and that is if start the last element in the array. So if they want me to tell them the sum of the array starting at location 2, which is the last element in my array, then I'm done also. I can just tell them that. So here I can say if array.length minus 1 is equal to start. I'm at the end of my array. So they're asking for something that is the last element. Then in that case, I will return array of start. Okay. So if they want just one element, I'll give them that element. Okay. And then when I want to do the next one, well, I'm going to say, okay, I'll give you what is at this location right now, plus start plus 1, the next one. So here, the way it would do it would happen. Let's go back and look at the code that we had written. Okay, with the helper. Where did it go? Here we go. Let's take that and modify it and copy it down here to kind of see what's happening. So I'll get some array with 147, comma 0. So this is going to say, okay, that means you want what's at location 0, which is the 1. Okay, so I'm going to give you that, which is over here. Okay, so I'm going to give you what's at location 0, and then I'm going to call some array with all of the array here. We're giving all the array, but now we want starting at location 1. So here we want starting at location 1. So when I come back to call some array on that, it's going to say, oh, you want what's at location 1, which is the 4. So I'm going to give you array of 4, array of 1, which is the 4. And then I'm going to call some array again with the whole array, but now I want what's at index 2. And when index 2 is called, it's going to say, oh, well, that's the last element in the array, so I'm just going to give you back the 7. And so if I run this, I should get 1 plus 4 is 5, plus 7 is 12. So let's try it out and see if we got the 12. And we do. So why did we need a helper method here? Because the way they asked us to do it, some array, you know, when you think of breaking it up into a smaller piece, there is no way for me to kind of take that array and take a part of it. It's not like a string. You know, if it was a string, you could use the substring to say, oh, I only want the last 2 characters in the string. But with arrays, I can't do that. Or if it's an array list, I can't do that. So you kind of have this little index that's saying, oh, which place am I on right now? I'm at 0. So I'm going to look at the 1. And then I'm done with the 1. So I want you to start now looking at location 1. So it's kind of saying start with 4 and ignore what's before it. And here it's saying start at 2 and ignore what's before it. So this is an example where we would need a helper method. Now, when would you need a helper method? When you try to write the method yourself and you find there's no way to do it, and that you need more information. And if you need more information, then you say, okay, if I need more information, how can I do it? Let's see what information I need, and I'm going to introduce those variables to make my life easier. So here, what I want you to do is write a recursive method called smallest numbers. It's going to take an array list of integers as input. And what it's going to do, it's going to tell me what the smallest number in the array is. And you're going to find that you're going to need a helper method to do that because, like we said, we have an array list. So we're going to have to kind of remember where we are in the array list. Where are you going to get this array list from that you're going to call smallest number with? You're going to get it from the user. So you're going to ask the user for a series of numbers until they enter a period. Once they enter a period, you'll know that they are done. Now here, because you're asking the user for something that could be a period, you're going to have to be asking them for strings, not numbers. And then you're going to have to use the integer.parseInt to convert that string to a number. So as long as while the user is not entering a period, you're going to read in that string, use the integer.parseInt to convert it to a number, stick it into the array list, and then you're going to call smallest number on that array list.